That was fun. Oh, as you can tell, I'm not going to be doing open book for this test. Instead, I have a sheet of paper that has everything I need to know on it. Anyways, Sniffy. There are 22 questions on this exam. Oh, great. Okay. A confidence interval is an estimate of the range of possible values. Gosh. You know what? I literally have the I'm just going to look up the definition. I have it. That's the nice thing about the study guide. That's the advantage of it. Let's see here. Confidence interval. What? Okay, so an interval that, with a stated level of confidence, captures a population parameter. I believe this is the answer. Of the range of possible values for a population parameter. So I believe this is correct. Man. Okay. General form of a confidence interval. Ha ha ha. I literally copied that right onto my paper. That's actually helping me a lot. Like, wow, this is helping me way more than I thought. But anyways, general form of a confidence interval. Like, now I don't have to rely. Dude, this is actually, like, easier to take the test like this. But anyways, where is it? Typical form of a confidence interval is point estimate plus or minus the multiple times the standard error. So point estimate plus or minus multiple times standard error. This is way easier than I thought. Because I looked at the study guide, obviously, and wrote down all the important information. But anyways, when we replace that with the sample, we introduce a new source of variability, and the sampling distribution becomes... Oh, crap. Oh, crap. Oh, no, I'm going to skip that one for now. I don't know. Dang it. The t-distribution for developing a confidence interval... Oh man, I think it's n-1. I didn't copy that down either. I think it's n-1. n-1. Dang. I hope we don't have to do a problem related to that. If you are constructing a confidence interval for a single mean, okay. Yeah, a few of these were quiz questions. I wish I had studied that. The quiz questions. Anyways. Oh, dude, the magnets fell off. Dude, the magnet of this fell off. Confidence. Okay, so if you increase the sample size, I believe the confidence interval will decrease. I believe it will decrease. The higher sample size, the more confident you can be, I believe. So it will decrease. Yeah, I don't know. And hold on a second. Great. I don't know. T-distribution. Normal. Which of the following statements are true? Exactly one has to be true. Exactly one has to be true, I believe. Null hypothesis. Null usually represents theory researcher. The null is usually the status quo, I think. Type 2. Oh, I forgot about that. No, okay. Oh, never mind. I literally have the definition of a type 2 error on my piece of paper. Never mind. Type 2 error occurs when null hypothesis is false but is not rejected. The null hypothesis is false but is not rejected. So the null hypothesis is incorrectly accepted. So it's incorrectly accepted when the null hypothesis is false. There. Power of a test is the probability. What? Oh, the power of a test. Oh, that's a term. That's on my piece of paper in front of me. This is so easy. When you have all this stuff right in front of you, instead of having to dig through all the information in all of your various tabs. But anyways, power, trying to look for it. Oh, it's actually on the other side of the sheet, probably. Wait, no. Where's power of a test? Oh no, I can't find it. Dude, I can't find it. What? No. I don't see it. Oh, I found it. Power is the probability of correctly rejecting the null hypothesis when it is false. Probability that we correctly reject null hypothesis when it is false. Reject it when... Okay, so power is correctly rejecting the null hypothesis when the alternative hypothesis is true. That was funny. Of type 1 and 2, which is traditionally regarded as more serious. Type 1, I think. Type 1, which is when you reject null hypothesis, but it's actually true. That's funny. Smaller p-values indicate more evidence in support. So the smaller the p-value, the more evidence supports the alternative hypothesis. P-value is considered convincing. Oh, I just love this one. So I believe this. Less than 0.01. One-tailed alternative hypotheses are phrased. So one-tailed is going to be this one. Next, which of the following is an assumption of a no? Groups have equal variances, I think. Population is normally distributed. I think both of them are. Man, that's something I didn't really study. I did read about that. Let's see. Yeah, I definitely don't have that on my sheet of paper. But I believe both of those top two are correct. Sample. Oh wow, we already got to the Excel questions. That's fun. Oh. Extra credit. Hey, extra credit. Let's go. All right. In statistical analysis, the burden of proof lies traditionally with the alternative hypothesis, I think, right? You have to have more proof for the alternative than the null. I'm pretty sure. So that's pretty similar to the other question. And then the only one I skipped was 3, of course. What is this? Great. F distribution? Where are all the other ones? Estimating standard deviations. Normal. F distribution, useful for estimating variances or something. Chi-squared. So standard error. I'm going to guess chi-square because it says in the definition that it's useful for estimating standard deviations. I don't know. Great. No, I don't know. I'm just going to skip 3 again and just do it at the end because I don't think I know the answer to 3. Great. So we have an hour and 47 minutes to do the rest of those. That's fine. There's going to be, I believe, 5 Excel questions. 1, 2, 3, 4, 5, 6, 7. Please tell me they're not all separate questions and that like a couple of them are like combined. Anyways. Exam 3 quality salaries. That's fun. They're probably going to be out of order in my stinking thing. I'm just going to click the first one and see what it is. In fact, I will name them all. I should have named them before. I'm stupid. Why didn't I name them? Man, not have to waste time. Total cost. Great. I should have named these before. I'll just name them as I go. What are we looking for right now? We have quality salaries. No, that's not it. This is just great. Why was I so stupid? I should have named these before taking the test. PM salary. Is that it? I don't know. 15? This has got to be it, right? There's 15 of these. This has to be it. I'm going to say this is question 16. Right? So I'm going to say this is number 16. And so I really hope this is correct. Like there's 70, it's like I'll double check the other ones just to be sure. Oh, come on. Yeah, clearly not that one. Yeah, not that one either. So, looks like this is number 16. That was funny. So, we have salaries. Construct a 95% confidence interval for the mean annual salary. Oh no, dude. Oh no. Oh, never mind. This is easy. All I have to do is descriptive statistics. Why is there two sheets? Okay. So descriptive, and this input range is going to be this. Labels in first row. Output range is going to be here. And summary, confidence level, 95%. And we're good. We're good here. Got that. So what are we looking for? Mean annual salary. So 95. So it's going to be the mean minus this. Plus this. And then total annual salary. All you have to do is multiply it by 15. So equals this times 15 equals this times 15. So save and we have 67,000, and this is this times 15. So what size of sample is needed to ensure that you can estimate the population mean salary of all quality managers? So we have part C up here, and we're going to use an equation. So the equation is going to be okay, so the equation is going to be equal to parenthesis, another parenthesis, and inside that parenthesis, we are going to do z multiple. The z multiple is going to be 1.96. Then we're going to multiply that by the estimated standard deviation. The estimated standard deviation is going to be 3,000. And then do a parenthesis and another, and then you're going to divide it by what? B. So they already gave us B. B is going to be equal to 500. And now you do all of this to the power of 2. And that should be it. So z multiple times 3,000 divided by 500, and you square that. So that should be it. And so what is the sample size that you need for blah, 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 138? Sample size for what? So apparently the answer is that, 138. So we're going to have 139. So construct the interval. Okay, so I think we're done with 16. That took forever. We're done with 16. So since we're done with 16, we close this, and we will now go on to 17. 17. So elect marked. We have 400 customers' orders. We have 400 customers' orders. Now which one is this going to be? Stop. And also, does it go on to the next question? No, it doesn't. Oh, I think this is it, because there's a lot of things here. Total cost of items ordered. What? How do I look at the note in full? Because it doesn't really show the whole thing. Oh, just make it bigger. There we go. So, total cost of items ordered on this purchase. And are there 400 results? There are 400 results. Dude, they literally give you the sum and the average right there. No way. That's great. So yeah, that's 400. That's 400 right there. That's a lot. That's a lot. So what are we doing here? Man, what if... So we should rename this file to number 1770E. Just double checking. Just double checking. This is a waste of time. I should have done this before. Great. So now what? Construct a 95% confidence interval for the mean cost of all customers' orders. Simple. That's fine. So for this one, create a column with 140 entered 400 times. Okay? In fact, let's move all this over by one. Great. Should have done that to begin with. Then we'll do that. Unfortunately, we have... I don't remember what to call this. I'm just going to call it... Oh my gosh. 140. Save. So let's go to the bottom just to make sure. So 140. And yep, that worked. So, and then we do choose the t-test assuming unequal variances. Man, I can't believe it just gives you how to do this problem. I don't know why. Oh, I'm stupid. That was fine. T-test. It's a t-test assuming unequal variances. Variable 1 is going to be this. Variable 2 is going to be this. And this. Holy crap. I got that text message way too late. Man, that's so annoying. Well, it's not like I barely had time anyway, so I guess it worked out. Oh my gosh. Oh man. We will put it right here. And good. So the mean is that, and we want the two tail, I believe, because it's. Are we trying to see if they're equal or not? Oh, we know it's one tail. It's one tail. We do want the one tail test. Probability t is less than or equal to t. Probability. Okay. So it's a one tail. Oh, yeah, I hate when I always click that accidentally. Maybe I should just put this over here because I keep clicking on an accident. Man. So the manager wants to know if they spend on 140 or more. 140 or more. So how much time do I have left? 126. So mean is, the alternative is more than 140. Is more than 140. And null is mean is equal to or less than 140. Mean is more than 140. So null equal to or less than 140. And thingy. Stop. So that's null. Report p-value. P-value is, well, we have it here. We want this one. So one tail. P-value is 0.002. So 0.002. Therefore, okay, this is less than 0.05, so reject the null hypothesis. And interpret results. Okay, so what does the results mean? Customers spend at least $140 per order. So, we can conclude that customers spend more than $140 per order on average. And what else? Do the results of the 95% confidence interval and this one sample t-test. Okay, so yeah, I know about that one. And well, I just want to fit on the page here. So confidence, do they contradict each other? The 95% CI and t-test agree. I don't know how to spell agree. Entirely above 140. And the t-test result was that the average was more than 140. Interval is entirely above 140, and the t-test result was that the average was more than 140. So that's it for that question stoppy. So we're done with number 17. Good job. Stop. Okay. Stop. So we're done with number 17. And which of the questions is going to be spread out over multiple questions for some reason? Let's see. So we have computer skills. So we have computer skills. And so it looks like the computer skills one is going to be one question. So where's computer skills question? That was funny. Let's see, what is this anyways? So training program. There's two tests, and so it's going to be a paired test. So let's see. So it looks like this is the one. Double checking though. So 97 looks like it's the one because there's a score before and a score after. Just going to double check. Stop. And nope, clearly not that one. Front aisle and rear aisle, and no. So this one right here is number 18. So we only have this, this, and this left. That was funny. We have an hour and 20 minutes. We have plenty of time. That was funny. There's 3 sheets of paper. I mean, Excel sheets. Dang it. Can I please just move this over here? Stop. Trying to determine whether they improved their score. Computer skills test. Records both the before training and after training score. Which t-test is most appropriate? So we can just type that into the answers here. So we'll just say A, the two-sample paired test. Paired t-test is the appropriate. That was funny. That because the score before and the score after are related. Each pair of results is related. One is results before training, and one is the result after training. I don't know what the correct wording on that is. So anyways, B, state null and alternative hypotheses. Okay, so B, H, 0, and HA. So the alternative hypothesis is that it improved the scores. So basically that mean of score. Okay, so HO, mean of score before is equal to or less, more than, and score after, mean of score before is less than score after, I think. Great. That's probably going to be wrong. Dang it. Also, this is all zoomed in, which is not good. I want to make everything have a smaller font size. I don't know why it's... Dude, it clearly is... What? Arial number 10? Let's just change it all to Calibri. What the heck? Man, why? Wait, oh no, it's just zoomed in. No wonder. Oh my gosh. 5%. Conduct the hypothesis test on the data. Jeez. Okay, so I know how to do this. It literally... Stop. Paired. You just look for paired. We have paired, t-test paired to sample for means. That is the correct one, right? It's got to be it. Dude, where's the F test? Oh. Variable 1 is going to be these. Variable 2 is these. And 0 labels. Put it here. And stop. So we do want the one-tail result. We do want the one-tail because stuff. Probability that this is less than or equal to t. So this is less than or equal to this. Oh, jeez. Basically, they're saying... I hate how it's so confusing because they always have the bigger t first, which is this one. Probability that this is less than this is clearly low. The null is mean of the score before. So p-value of 0.0001. This is less than 0.05, so reject the null hypothesis. We can conclude that the mean of score before is less than mean of score after. This is evidence that the training program results in increased scores. And is therefore effective at is effective. That was funny. Oh. And increasing the new employees' computer skills. So I believe we're done with that. Stop. So we only have 2 of those of the Excel sheets left to do, or Excel files left. But for some reason, there's a lot more questions. So let's see. Mayor toy sales. Wait, what? What's number 22? Oh, there's another extra credit. Let's go. Alternative hypothesis is also known. Oh, geez, I don't remember. Do I have it written down somewhere on the thing? Let me just see. Oh my gosh, the answer is on my piece of paper. It's the research hypothesis. That's awesome. That's awesome. Research hypothesis, free 2 points. That's the advantage of copying, of like taking a million screenshots of all the key terms and putting it on a piece of paper. Dude, what? So alternative hypothesis is also known as the research hypothesis. So the last 2 questions were just multiple choice. That's great. We only have 2 more left. We only have a whole hour and 10 minutes to do these 2 questions. I love how I got my text message 2 hours late. Thanks a lot. So, major. How do you even pronounce that? I'm going to just say major. Whether the product location has any effect on the sale of children's toys. Two different aisle locations are considered. We have 18 stores selected. 6 stores randomly assigned to each aisle location. Well, I'm so glad they gave me the answer to how to do the question. Oh my gosh. So the front and rear Excel thing is going to be the relevant one. So it's going to be this one, which is number 19. And also, I'm almost at an hour. You know what? Let's just get it over with. That was funny. Bye.